Hare Krishna. Hope you're doing well. Let's get started with this question simply about expectation and inherently integration, chi-square distribution, because square of normal distribution, which is what is involved, leads to chi-square, and there is an element of gamma functions as well. Okay, let's get started. We simply have to find that constant C for which this expectations become sigma. So this thing we would anyway expect to be close to sigma square or in expectation around sigma square, right? Because summation xi square by sigma square when we it's the chi-square variable with n degrees of freedom. So when we take sigma square on outside away from this expression, the expectation will become equal to sigma square. Okay. One way to start it is to notice that okay, this square root thing is very complicated. Okay, but I also know that using the variance expression I can get rid of the square root issue by writing it like this, right? Variance of a random variable is equal to expectation of its square minus the square of its expectation. So this part is what we want to know, and this thing makes the square root vanish. But the pitfall over here, at least if you don't know the variance part, is you still have a square root that you have to deal with. Again, if in the exam you do happen to know a compact version of this variance part and you also know this, then it makes sense to write this in terms of these two. But if you don't, then this is just going to be a waste of time. So that's why we have to do some raw computation over here. But we can do it flexibly also, because we know that this thing follows chi-square 5. So we can start with this thing itself, the expectation of square root of it, because essentially this would mean looking at this thing, right? Now instead of this sigma on the RHS, you have this thing 1 on the RHS. We just made a tweak to the distribution to deal with it in a faster manner, because otherwise you would have to adjust for this sigma at the end also. So you just adjusted it for it now. So this kind of flexibility is fine. Okay. Now what I don't like about this question is the part that you have to remember the chi-square PDF. But yeah, there are some questions like this. And this is the PDF, and you multiply by the square root part, and then the constants come out, and what remains becomes a gamma function when scaled by 2, when we transform the variable y to y by 2. And we should also know the gamma function, by the way, that gamma alpha is essentially 0 to infinity y to the power alpha minus 1 e to the power minus y dy. And gamma alpha plus 1, this is a property of gamma function, alpha times gamma alpha, and gamma half equals to root pi. These three things must be known about the gamma function. So when we express this in gamma function, we simply use the properties of gamma function. And yeah, also if gamma alpha is an integer, gamma alpha is simply alpha minus 1 whole alpha minus 1 factorial. So this gamma 3 becomes 3 minus 1 2 factorial, which is easy. But this 5 by 2 we have to write it in terms of this thing. First 3 by 2 plus 1, then half plus 1, leads us to which eventually leads us to this quantity. So the expectation of root y is this, but we want this expectation to be 1. So we simply take it on the LHS by inverting it. And our answer is root over 9 pi by 2 to the power 7, which is this root over 9 pi by 128. That was it. Take care. Hare Krishna.